Put your hand on your chest right now. Feel your heartbeat. Count 3 beats. 1, 2, 3. While you were counting, your brain was doing something you did not ask it to do, something it has been doing every single night for your entire life, and something that will cost you or make you money before the end of this week. You do not know it is happening, you cannot feel it, but the numbers are extraordinary. The average person loses or misses $2,200 every single year because of what happens to their brain while they sleep. Not from bad decisions, not from ignorance, from biology. A specific sequence of events unfolds inside your skull during the hours between midnight and 6 in the morning. A molecule surges, a gland activates, a region of your frontal lobe goes offline. And when you wake up, that sequence has already preset your tolerance for financial risk, your susceptibility to impulse spending, and in some cases, your likelihood of making or avoiding a major financial decision that day. This has nothing to do with how rested you feel, nothing to do with your discipline, nothing to do with your income or your education. It has to do with a 22 amino acid peptide released by a gland the size of a grain of rice in the center of your brain. The number is 2.4. Remember it. You are about to understand something most people never hear. Most people believe that sleep affects the body the way rest affects a machine. It repairs what is worn, clears what is full, and returns everything to baseline. That is the folk understanding, and it is almost entirely wrong. What sleep actually does is not passive maintenance. It is active chemical manufacturing. Your brain does not slow down at night. It shifts industries. It stops producing the molecules needed for social performance, and it begins mass producing molecules that govern how you assess value, weigh risk, and feel about the future. The difference between a sleeping brain and a resting brain is the difference between a factory at lunch break and a factory that has switched from making cars to making weapons. The machines are running. The output is completely different. What most people assume is that financial decisions are made by conscious reasoning. Choose the logical option, resist the emotional one. That is not how decisions are made. That is how people describe decisions after they have already made them. What is actually happening is that before you open a single browser tab, before you pick up your phone, before you walk into any store, your brain has already pre-negotiated your emotional relationship to money that day, based on what happened inside your skull while you were unconscious. The difference between a brain that slept well and a brain that did not is the difference between a pilot who has calibrated his instruments and one who is flying by the feeling in his stomach. Here is the physics. In the center of the brain, roughly level with the bridge of your nose, sits the hypothalamus. It is an ancient structure. It predates the parts of your brain that do language, planning, and self-awareness by several 100 million years. And in the hypothalamus sits a cluster of neurons called the suprachiasmatic nucleus, roughly 20,000 cells, a structure about the size of a grain of sand, stacked on top of the optic chiasm where your two optic nerves cross. This is the master clock, not a metaphor, a clock. It fires with almost perfect 24-hour periodicity, with or without any input from the outside world. Isolate a suprachiasmatic nucleus neuron in a petri dish, supply it with nutrients, and it will keep cycling. Approximately every 24 hours, it will fire and rest and fire again, alone, with nothing to set it by. That clock sends chemical signals to the pineal gland. The pineal gland is a structure so small and so centrally located that ancient anatomists once believed it to be the seat of the soul. René Descartes, in 1649, wrote that it was the point where the mind and body joined. He was wrong about the soul. He was right about the importance. The pineal gland receives its signal from the suprachiasmatic nucleus through a pathway that runs out of the brain, down the spinal cord, into the superior cervical ganglion, and back up again. A loop, a slow relay. And what it releases at the end of that relay is melatonin. Melatonin is N-acetyl 5-methoxytryptamine. It is synthesized from serotonin by two enzymes, arylalkylamine N-acetyltransferase and hydroxyindole O-methyltransferase. It is released into the bloodstream and into the cerebrospinal fluid simultaneously. Blood and brain flooded at once. In 1958, a dermatologist named Aaron Lerner at Yale School of Medicine isolated melatonin for the first time from the pineal glands of cattle. He had been searching for a substance that could change the color of frog skin. What he found instead was something that would eventually rewrite our understanding of how biological time is kept. He published in the Journal of the American Chemical Society, a short paper, almost casual in its tone. What Lerner did not know, what no one would know for another 3 decades, was that the molecule he had isolated from bovine pineal glands was also directly influencing how mammals assessed future threats and made decisions. Under uncertainty, he found the clock. He did not find the wallet. Let that settle. In 1994, Dr. Josephine Arendt at the University of Surrey conducted a landmark set of studies on melatonin and cognitive performance in conditions of disrupted circadian rhythm. Her subjects, shift workers, transatlantic travelers, people whose light exposure had been deliberately manipulated in lab conditions, showed measurable changes in what she called executive function. Not just drowsiness, not just mood, the specific cognitive abilities that govern planning, self-regulation, and decision-making under uncertainty. Arendt published in the Journal of Sleep Research. Her finding was specific. Disruption of the melatonin cycle did not simply impair memory or reaction time. It impaired the brain's ability to correctly evaluate future reward versus immediate reward. The long clock went wrong and the short clock got louder. The short clock is the one that wants the thing now. Think about that. Now here is what that means for your body. The first mechanism is this. During the deep stages of sleep, the stages neuroscientists call slow-wave sleep, characterized by large synchronized delta waves sweeping across the cortex, the prefrontal cortex goes substantially offline. Substantially. Not completely, but enough. The prefrontal cortex is the part of your brain that handles delayed gratification, future planning, and the inhibition of impulses. It is the part that says wait. During slow-wave sleep, the activity in that region drops dramatically and the brain performs something called synaptic homeostasis. It prunes, consolidates, and resets its networks. In that process, the balance of activity in the brain tips toward the limbic system, the emotional, reward-seeking, threat-responding system. When morning comes, that balance does not reset instantly. It resets gradually. And in a brain that did not complete enough slow-wave cycles, a brain that was interrupted by an alarm, by stress, by alcohol, by artificial light at midnight, the reset is incomplete. The prefrontal cortex is slower to come back online. The limbic system stays louder for longer, and the ratio of impulse to restraint is tilted. This is not a mood. This is a neurological state. There is a second mechanism operating at the same time. During the second half of the night, the hours between approximately 3 a.m. and 6 a.m., the brain produces its daily surge of cortisol. Cortisol is synthesized from cholesterol in the adrenal cortex, carried in the bloodstream, and received by cortisol receptors throughout the brain, including dense concentrations in the hippocampus and the amygdala. Cortisol is not a stress hormone in the way the word implies. It is an arousal hormone, a preparedness hormone. Its morning surge is what begins to peel your brain out of sleep and return it to waking function. But cortisol also amplifies the brain's sensitivity to reward signals. It does not just wake you up, it makes you hungrier for food, for stimulus, for acquisition. Dr. Clemens Kirschbaum at the Technical University of Dresden measured cortisol's direct effect on economic decision-making in 2010. His team used the Iowa Gambling Task, a standardized measure of risky financial decision-making, on subjects with elevated cortisol levels induced through controlled administration. The results were striking. Elevated cortisol did not make subjects more anxious and cautious as you might expect. It made them risk-tolerant, more likely to choose high-reward, high-risk options, more likely to ignore cumulative losses in favor of the next potential win. A cortisol surge does not make you careful. It makes you hungry. And there is a third layer. Dr. Matthew Walker at the University of California. Berkeley published findings in 2007 in the journal Current Biology showing that sleep-deprived brains, subjects kept awake for 35 hours, showed a 40% increase in amygdala reactivity, emotional stimuli compared to controls who had slept normally, 40%. And critically, the connection between the amygdala and the prefrontal cortex, the pathway through which the rational brain can dampen emotional responses, was significantly weakened. 3 mechanisms, all triggered by the same nightly biological event, all operating below conscious awareness, all converging on the same behavioral outcome. A sleep-disrupted brain is more impulsive, more reward-hungry, and less capable of applying its own brakes. This is not willpower, this is neuroscience. Now here is the part most people never hear. In 2013, researchers at Uppsala University in Sweden led by Dr. Christian Benedict, published a study in the journal Obesity examining food purchasing behavior after a single night of sleep deprivation. The study measured not just what subjects said they intended to buy, but what they actually bought. Total caloric content of items selected increased by 9% after one night of poor sleep. Total monetary value of items purchased increased by approximately 18%. A single night. 1. And food is only one spending category. In 2015, researchers at the Wharton School at the University of Pennsylvania analyzed consumer spending data across multiple categories: retail, restaurants, entertainment, and impulse purchases, and found that the highest spending days per person were correlated with the lowest sleep periods in the data. The relationship held across income groups. It held for high earners and low earners, across genders and ages. For the average person spending $45,000 annually on non-housing expenses, an 18% impulse purchase premium on chronically poor sleep nights, nights that for most adults occur 2 to 3 times per week, amounts to roughly $2,200 per year in unplanned spending. That is the $2.4 thousand. Now you understand the number. Think about what that means for your life. The system that exploits this is not subtle, it is engineered. Every casino in the world operates without windows and without clocks. This is not an accident, and it is not tradition. It is the deliberate removal of the two environmental signals that the suprachiasmatic nucleus uses to keep the master clock calibrated, light transitions, and time markers. A brain inside a casino is a brain whose circadian signals have been deliberately jammed, which means its melatonin cortisol cycle runs without environmental correction, which means it stays in a state of elevated cortisol and reduced prefrontal inhibition for as long as it remains inside. The average casino visitor spends 4 hours longer on the floor than they planned to when they walked in. This is not bad judgment. This is biology in a deliberately constructed environment. The digital version of this is more pervasive and more personal. Major retail platforms and financial services apps use push notification timing calibrated to the period between 7 and 10 in the morning. The window of peak cortisol specifically because behavioral data shows conversion rates for impulse purchases are highest in that window. This has been documented in internal research from a major e-commerce company, published in summary by behavioral economist Dr. Keith Wilcox at Columbia Business School in 2016. Morning notifications. Cortisol amplified reward sensitivity. A prefrontal cortex still completing its reboot. The credit card industry has known about sleep and spending for decades through observation, even before the neuroscience arrived to explain it. Cards with no spending limits, marketed explicitly to high net worth consumers, are deliberately exempt from the friction that lower tier cards impose: no automatic flags, no SMS alerts for unusual spending, no soft stops. The friction is what the prefrontal cortex needs to do its job. Remove the friction during a cortisol surge and the limbic system purchases alone. The estimated annual cost across all categories: retail, dining, entertainment, financial instruments attributable to sleep-disrupted spending behavior is approximately $2,200 per affected consumer per year. This is an extrapolation from controlled studies, not a direct measurement. Your number depends on your income, your baseline spending patterns, and how many nights per week your sleep is disrupted. The mechanism is real. The dollar amount is an estimate. The direction is not. Now here is where the evidence sits. The melatonin circadian mechanism data sits on the top shelf, measured directly, replicated, peer-reviewed across 6 decades since Lerner's original isolation. The connection between sleep disruption and prefrontal impairment sits on a solid middle shelf, consistent across Walker's imaging studies, Arendt's circadian research, and Kirschbaum's cortisol decision work, but not yet measured with the resolution to tell you exactly what your specific impairment is on a given Tuesday morning. The $2,200 annual cost sits on a reasonable shelf extrapolated from controlled purchasing studies, internally consistent with the neuroscience, but your personal number depends on your baseline sleep quality, your income, and what you happen to be offered during your cortisol window. The viewer should know which shelf each claim sits on. Put your hand on your chest again. Feel your heart beat. Count 3 beats. 1, 2, 3. While you were sleeping last night, your suprachiasmatic nucleus was firing its 20,000 cell clock. Your pineal gland was converting serotonin into melatonin and releasing it into your blood and into your cerebrospinal fluid simultaneously. Your prefrontal cortex was going offline and pruning its synapses. And then in the last hours of the night, your adrenal cortex was synthesizing cortisol from cholesterol and flooding your waking brain with a molecule that makes reward signals louder and inhibition quieter. By the time your alarm went off, the negotiation was already over. Your brain had preset its stance toward risk, reward, and acquisition not from your choices, not from your character, but from the chemistry of the hours you spent unconscious. Before you open your phone in the morning, before you check notifications, before you open an app, before you look at prices, wait. Not 10 minutes, not an hour, 90 minutes. The research from Walker's lab suggests the prefrontal cortex reaches closer to full online function approximately 90 minutes after waking in a normally rested individual. Cortisol has begun to descend. The limbic amplification has quieted. The pilot has recalibrated his instruments. 90 minutes, not as a spiritual practice, because the factory has switched back